We're told here that we're going to make an investment through Chase and that the nominal annual rate is 0.10% compounded monthly, and this is for any balances between $0 and $9,999. In letter A, we would like to know how much a person would have in retirement in 30 years, assuming the constant rate of 0.10% and a single deposit of $8,000. We could go one of two ways. Formulaically, we know that this is going to be 8,000 at 1 plus the effective rate, or the periodic interest rate, which is the percentage written as a decimal, which this one would be 0.001. This is compounded monthly, so we have to divide that into 12 chunks. And now we're going to be doing this for 30 years. Well, how many months are there in 30 years? 30 years equals 12 times 30 months, which is going to be 360. So 360 months later, we're going to find out what we have. And this is a calculator entry problem. So I'll just go ahead and enter this whole thing in the way I see it. I don't actually need to enter the I separately. I can just do it in one swing because I don't really care what the effective interest rate is. So I'll do 0.001 divided by 12, and I'll raise it to the 360 power. And that gives me $8,243.63. So not very much made on this, assuming that this rate does not change. So that's a very, very bad, very, very low rate. And alternatively, we can come over into TVM Solver, and the way we'll do that is hit Apps, Finance, TVM Solver, and we'll modify everything here. Well, our capital N is 360, that's the number of compounding periods. The percentage, we have to remember, this one wants the actual percentage, and it wants the nominal annual rate. It wants that, i.e. the APR. So nominal annual rate, APR, same thing. Initially, well, if I draw myself a little timeline here, what's going to happen today? Well, today I'm going to outflow $8,000, and I want to know what happens in 360 months. So if I outflow $8,000, I'm going to make this a negative because it's leaving my body. Payment, there is none, so we want to leave that as 0. We will calculate our future value. We want our compounding periods to be set to 12, and now we'll hit alpha, enter, and we confirm that it's $8,243.63. So 8243 and 63. That's going to be our inflow. That's money that we'll receive down the line. Part B asks, how much would a person have in the account at retirement in 40 years, assuming a constant rate and a single deposit of 8,000. So same problem, except we're looking at 40 years instead of 30 years. So how much of this 10-year gap, or how much difference would this 10-year gap make? Well, as we know, we can come over here and just type in 12 times 40 to get the total number of months, which will be 480. And we're still depositing the same amount, but we want to calculate the new future value, so hit alpha, enter. And not surprisingly, it's not very much more. So now the same investment, but this is 40 years later, 480 months, I only get to bring in $8,326.47. So still a very bad investment, and doesn't help that we have that extra 10 years. In part C, we'd like to know how much would a person have to invest in order to have $100,000 at retirement in 40 years. So we're going to set up what we know and what we need, and we don't know the amount that the person has to invest, so I'm going to put a question mark here. That's what we're trying to figure out. But I know I want to be able to have $100,000 in 40 years, so that's going to be 480 months, and it's going to be 480, and that's what I need to calculate. So I actually need to get my present value here. So I know that my future value is going to be an inflow of 100,000. I'm going to get that money at that time. No payment, and this is going to be 480 months at 0.1% APR. And now I'll calculate the present value. So I pretty much have to put in the entirety of that dollar amount, $96,000 $79.10. And that is a considerable amount of money to be able to put in, to be able to have $100,000 in 40 years. In part D, we want to know how long would it take to have $100,000 in the account on an initial deposit of $8,000. So in part D, we know that we're going to put in $8,000 and we want to have received $100,000, but the question is, how long would that take? So how long would it take for, what would n need to be in order to accomplish this? Well, given that it's still 0.1% compounded monthly, my present value is an outflow of $8,000, and my future value is $100,000 with no payments, I'm going to come up here and calculate n, so I'll do alpha, enter, and this will take 30,310. Well, actually, we got to be careful here because it's a little bit more than 30,310 months. So we should probably round up because they don't pay us interest in the middle of a month. So we'll round this up, and this will be 30,311 months, which we could calculate to see how many years that is. 30,311 divided by 12. And that comes out to, that's about over 2,500 years. So at this interest rate, things are not looking so good. Finally, what is the APY on this account? Well, APY formula we know is equal to 1 plus the periodic interest rate. Now, since this is compounded monthly, this will be to the 12th power for 1 year. Subtract away 1. So I is going to be our APR, written as a decimal, divided by 12, raised to the 12th power, minus 1. And we will type that in. 1 plus 0.001 divided by 12, and raised to the 12th power, subtract away 1. So we actually notice that the APY is not that much bigger than the APR. It is a little bit because technically this is 0.10004585%, and that's technically bigger than 0.1%. So we do get a little bit of a bigger yield, but it's pretty insignificant.